Hey, APStat. So we're going to continue in finding areas of the normal distribution, and we're going to focus now going beyond the empirical rule, beyond that 68, 95, 99, 7 rule. So what do we do in situations where we have cutoffs if we're looking for areas under the normal curve that don't correspond to exact standard deviations away? So here we've got these ITBS vocabulary scores. Looks like the mean is 6.84. The standard deviation is, I don't know, whatever the difference between those two numbers is. And so we're looking for an area under the normal curve corresponding to this region. Well, without calculus, we need another way to do this. What we do is actually, first thing we need to do is we need to standardize, get it into a format. There's not a table that exists for this, but there is a standardized table of probabilities for this. So first thing we're going to do is standardize this and get it in terms of z-scores. And so if we basically do the entire distribution in terms of z-scores, if we take the value minus the mean divided by the standard deviation, we can figure out how this would look on a standardized normal curve. And it would look something like this. So for this particular 6, apparently the z-score for that is a negative 0.54. It's about a half a standard deviation, a little more than a half a standard deviation below the mean. So you'd find the z-score for that. But notice that we've got 1 standard deviation above, 2, 3. That's what those z-scores would be. Negative 1 is 1 standard deviation below, 2, 3. So this is the standard normal distribution centered at 0 with a standard deviation of 1. And once we are in this, we can actually use that z-score, that negative 0.54. We've got a table that will tell us the area under the normal curve, and I'll show you that in a second. So the process I want you to go through when finding probabilities, especially beyond the 68, 95, 99, 7 rule, is draw a normal distribution. So you can use the mean and always label the mean as the center, the standard deviation, one like standard deviation away, and the distance away is like where it's actually under the inflection points of the curve. It's where the curve direction changes. That's 1 standard deviation away, and then 2, and usually I draw like 3 standard deviations away because we know that covers most of our distribution. So make sure you got that labeled, a well-labeled curve with means and standard deviations labeled, and then boundary values. So boundary value is like if you're going in an interval and a range for your normal distribution, or above a certain value or below a certain value, make sure you label that boundary value, and then shade the area of interest. So I want to go above, shade that area to the right, or if you want to go below, shade the area to the left or in between. So make sure that you do that, and then you perform your calculations showing work. There's a couple of options. I'm going to recommend one of them, but you have a couple of options. So you can standardize each boundary value and use table A. So you find z-scores for your boundaries, and then use table A to find the areas between them, or technology to find the desired area under the normal curve. That's actually what I'll probably recommend, is technology. And then if your technology can work with z-scores. Your technology can actually do it without standardizing. It kind of standardizes for you in the background. I'll show you that in a second. And then be sure to then go back and answer the question was asked, put it back in the context of the question. So let's do this looking at an example. So getting back to that same data, the distribution of ITBS, Iowa Test of Basic Skills vocabulary scores among all Gary, Indiana 7th graders. So recall the distribution was approximately normal with mean 6.84 and that standard deviation 1.55. What proportion of these 7th graders have vocabulary scores that are below a 6th grade level? And so that's what that basically we're looking for, below 6. So first step, draw a normal distribution with the horizontal axis labeled and scaled using the mean and standard deviation and the boundary values, and indicate that area with a shaded area. So here's what that would look like. We draw our normal curve first. If this is our actual distribution, this is our standardized distribution where they're showing it in terms of z-scores. I actually will take either of these, and honestly, I actually prefer this one because it's just easier to write 0, 1, 2, 3 rather than have to figure out what all these numbers are. I just can standardize one value. So this is actually kind of the graph I'll prefer to show when doing this. But you can write it this way. I can show the original mean, show 1 standard deviation above, 2, 3 above, 1, 2, 3 below, show your boundary value, and then shade the region. But we can also do it standardized in terms of z-scores and do that. All right, so then the next step is to actually perform your calculations. So you can do one of the following. You can either use the table A or you can use technology. So table A, what the heck am I talking about? So So here, you know, this will show a little bit of this table where they have z-scores. Let me show you where this is in your book. So if you open up your textbook to the back, very near the back, the last few pages we get into some tables, and so these are actually tables that are given on the AP statistics test. We've got this one here, it's got this funny little symbol, that's chi-square, we don't need that for now. We've got this one here with T, I don't know what that is, we'll figure that out at some point. So this is what we want, Z. You've actually got 2 pages, it's on page T2 and T1, and this is actually known as Table A, and this is how it's known on the AP test. And so that's when you see when you see these slides referring to Table A, you know, when it refers to Table A here, use Table A. That's what it's referring to. And so what's been done in this table is somebody's gone through, and for every z-score, so they've got z-scores out to the 10th place here, and then actually the columns take us to the 100th place. So if you want to look up a z-score for a particular value, you can find this there, and in the table you tell it the z-score, it'll give you the probability or area below the curve, the proportion of that distribution. So if we go back to our problem here, where am I? If we go back to our problem, we are ultimately looking for the area below negative 0.54. And so this table, what they've shown us, below negative 0.54, they've shown us a little bit of a table, a chunk of it. I'm going to go back and show you the whole thing, but at negative 0.54, this little value right here, they're going to show us, yeah, we use this value, this row, and then that column, negative 0.54, this is that area. So this green area, or bluish greenish area here, is 0.2946. That's the proportion of the normal curve below that, and ultimately going to be our answer to this question. But let me show you it again in the textbook, because this is what you'll probably be using. You'll flip back to this page, yeah, you can use this table to find those probabilities. So on this page we got a negative page, and if I turn the page, we've got our positive page here on the other side, and these areas will end up being like more than 50% on this page, and you'll notice that these areas, or this table always just does the area below, the area less than a particular value. So we want a negative 0.54, so actually we're looking down here, negative 0.5, and then so again the little table they showed you in the PowerPoint is not nearly as big as this thing actually is, and then I look at this 4 column and I track this down, negative 0.5, and then this is my 4 column, and we see that 0.2946, right? And that's what this was showing here, just in a you know, a smaller snippet of that. So you can use that table, and if I want to do the area above, you can subtract from 1 and do things like that. Honestly, like, don't use the table. It's there. I kind of feel obligated to show you because that's like a big thing, like the test. But calculators are just better for this. So let me show you how to find that probability in your calculator. So if we bring up our calculator, we're going to use the stat button a lot. We're going to use stat plot. The other thing we're actually going to use is right here, distribution, D-I-S-T-R, distribution. If you go second, distribution, we're going to use several of these throughout the year, but the one that we're going to want is actually normal CDF, normal cumulative distribution function. This is the thing, this is the command in our calculator that'll give us the area under the normal curve. All right, so this, and we're going to use inverse norm as well here very soon, but normal CDF, what you do is you give it lower bounds, upper bounds, you tell it the mean and standard deviation. If you leave the mean and standard deviation as 0 and 1, you can do this problem in terms of z-scores. So I can go from a z-score of, well, this is kind of weird. What is our lower bound? Our calculator wants us to do a lower bound. Well, if we look back here, our lower bound in this curve it's not actually -3. It technically goes on to negative infinity. So that's what I'd like to use in my calculator. My calculator can't handle negative infinity though. So you do actually have to give it a value. you could choose anything that's like negative and extreme. The actual lowest number our calculator, I believe, can handle, this is at least what I've been told, I don't know, maybe you can play around with it and see if that's true, is this -1 E99. So this E is actually scientific notation. The way I got that, I typed in -1, and then I hit second, and then where this double E is, that's scientific. It's again like our calculator's version of scientific notation. So this is -1 times 10 to the 99th power. So it's a 1 and then 99 zeros after it. I believe that's the maximum number of digits that this calculator can hold, like in its memory. If you go beyond that, you'll like break your calculator. So not actually break it, but all right. So then I want to go from there, from effectively negative infinity, not actually negative infinity, but for our purposes, it'll be good enough. So we're going to go from that really low bound and then we're going to go to an upper bound, and this is going to be what we're shooting for here, is this upper cutoff in our area. And so we're going to type in that -0.54. I'm actually going to do this as z-scores first. So we're going to type in -0.54. And then I'll leave this as 0 and 1. That's actually, we're going to leave this as a standardized normal curve, 0 and 1, right? Because in this graph, we're working with a standardized normal curve with its mean at 0 and a standard deviation of 1. So if I do that and then hit enter or hit paste, this is actually the command that's going on in the background. And if you actually don't have the TI-84, you actually just have to memorize this process of which one goes first: lower bound, upper bound, mean, standard deviation. It's kind of annoying. If I do have an app that can help you with that, so let me know if you're in that situation. I can help you out. But most of you guys, I think, have 84s, and it'll help you through this. And so if we hit enter, it's going to give us that number that we just calculated, the 0.2945. It actually gives us out to 10 decimal places, but 2946 is what our thing set over here. All right, and that's giving us that same value. So once you get comfortable with the calculator, this is the better way of doing it. And so here they're actually showing that they used a -1,000. Yeah, -1,000 is enough. You don't even need to go that far. You could -1E99, -1,000. You could go to -10, and it's going to be enough. 10 standard deviations below the mean. The area is going to round off beyond 4 decimal places. Yeah. So, but I just use that because it always works. -1,000 may not work. It'll work in Z always, but it won't always work in other situations. So that's one way of doing it. The other way you can do this in your calculator is we can do this without it standardizing ever. So I can actually, sorry, instead of hitting second enter, I'm going to do this again. Second distribution, normal CDF. We can do lower bound. I'm going to leave that lower bound the same. I'm actually going to go up to 6, which was our original max, and then I'm going to type in our original mean and standard deviation. These were 6.84, and the standard deviation was, oh crap, I can't see what it is right now. 1.55. 1.55 was our old mean and standard deviation. So what our calculator is going to actually do is it's basically going to take this value and standardize it. It's going to do minus the mean divided by the standard deviation and find the z-score for us, and then find that area for us. So this also works. Lower bound from negative infinity up to 6 with the mean 6.84 and standard deviation 1.55. Notice that probability is virtually the same. The reason that these aren't exactly the same is actually because this z-score was rounded. That -0.54 wasn't exactly right. It was really, should have been 6. I think it minus 6.84 divided by. I just made a common mistake. Don't do that. What I just did here, the way I typed it into my calculator, it did the division. It does order of operations, so I forgot parentheses. So. Glad to show you that common mistake, but crap, taking my extra time. Parentheses around that subtraction. Now we'll get, so that z-score was really not -0.54, is this. And so that's why there's a discrepancy. This second number here is actually a little more accurate. But as long as you're within, I mean, that's within a very short range of each other. It's 29.4-ish percent of the distribution. So that is, that's the other way that we can go about doing this one. So actually here, they got the slide for this one. So yeah, they've done it using the lower bound of still -1,000, and then 6 is the upper bound, and mean and standard deviation typed in, and they got that probability. All right, and then final step is make sure you answer the question. Don't just write this and don't write down like, you know, this notation. And if you are going to use your calculator, there's this weird thing. I like to see the graph, the picture of it, where you show a picture. That's enough to constitute work. Just writing calculator syntax is not enough, but they will accept it on AP test if you write like what each of these things in. That this is lower bound, upper bound, mean, and standard deviation. You actually have to kind of write it inside that statement. It's kind of weird that they accept that. I don't love that. I actually prefer to just see the picture, since that's, you know, that shows that distribution. And if you just label a picture, you don't actually have to write this stuff down at all. You can just label that area and write that as, you know, this point, draw an arrow to this and say this is 0.2939 or whatever you get for that. But then finally, make sure you answer the question. The question was, what proportion of these 7th graders have vocabulary scores that are below the 6th grade level? Then we want to actually write down our answer, and our answer would look something like this. We estimate about 29.4% of Gary, Indiana 7th graders scores will fall below the 6th grade level on the ITBS vocabulary test.